Hello student, welcome again. In the previous video lecture, we have started ionic equilibrium. Okay, and in that video, we have seen the chemical equilibrium, ionic equilibrium. We also have seen electrolyte. We have seen the strong electrolyte, weak electrolyte, and we also have seen the degree of dissociation. And then we move towards the acid base concept, and we have started the Arrhenius theory of acids and bases, and we also have seen the limitations of Arrhenius theory. Now in today's lecture we are going to see the Bronsted-Lowry theory of acids and bases. Students, according to the Bronsted-Lowry concept, acid is a substance which donates protons, that is the H positive ion, to the another substance. Okay, and acid is a substance which donates proton, that is the H positive ion, to the another substance, and the base is a substance which accepts proton from the another substance. Means if anyone is giving the H positive ion, there must be a acceptor. Therefore there must be acid and base. There are both the substances should be present. Now we will see the one of the example. Now in this example, suppose this is HCl and NH4. This is the reversible reaction, and it gives the NH4 positive ion and the Cl negative ion. Okay, now in this reaction, if you consider about this HCl, and if you consider about the NH4 positive ion, okay, so both these substances, HCl and the NH4 positive ions, this donates the proton. It contains proton, therefore it will donate the proton, and therefore it is a acid. This is the acid 1 and this is the acid 2. And if we will see about the NH3, that is the ammonia, and the Cl negative ion, both of these will accept a proton. Both of these will accept a proton, therefore it is a base. Therefore both these substances are bases. Therefore it is the base 2 and it is the base 1. Okay. Now if we consider this reaction, complete reaction, if we consider this complete reaction, then we can say that this is the reactant side, right? This is the reactant side and this is the product side. Okay. In this reactant and the product side, we can say that whenever this acid and bases, both the acids and bases reacts to give again the acids and the bases, that is we can say that the products of the Lowry-Bronsted acid base, the product, this is the product of the Lowry-Bronsted acids and bases is the reaction between the acids and the bases. That is we can say that whenever there is a reaction between the acids and the bases of the Lowry-Bronsted concept, we will also get the product will also be there, the acids and the bases. Okay, now we will just go towards the concept conjugate acids and base pair. Okay, what is meant by this conjugate acid base pair? First of all, we will see this a pair. It is a pair of an acid and a base which is differ by a proton. Okay, there is only a difference of proton or the presence or absence of a proton. It is known as the conjugate acid base pair. Okay, a pair of an acid and a base which is differ by a proton or a presence or absence of a proton. We will see that this whenever an acid donates a proton, it changes to a base. Now this HCl will consider here. The HCl will donate the proton, that is the H positive ion. Okay, suppose it donate a H positive ion, then it will get converted to a base. Now if this Cl negative is the base, right? this Cl negative is the base of this HCl. Okay, and if we'll consider about, and a base accepts a proton, a base, this is a base, this base accepts a proton and get changes to an acid. Now here the H2O molecule accepts a proton, okay, and therefore it get converted to a acid. That is, we can say that whenever an acid donates a proton, therefore it get converted to a base. यहाँ पे इसका बेस में कन्वर्जन हो गया है, यानी कि इस एसिड का बेस में इधर कन्वर्जन हो गया है. और जो भी कभी भी कौन सा भी बेस है, whenever it accepts a proton, whenever a base accepts a proton, then it get converted to an acid. Here the H3O positive is the acid. Okay, now here we can say that suppose this HCl is an acid, तो उसका जो बेस है, उसका बेस जो है वो Cl नेगेटिव आयन, क्योंकि HCl से ये प्रोड्यूस हो गया है. whenever HCl donates a proton, a base is produced. therefore this is acid 1 and therefore it is base 1. okay, therefore we can say that this is the conjugate acid base pair. Conjugate acid base pair. This now if we consider about the H2O molecule and the H3O positive ion, then we can say that this is a base because it accepts a proton, right? This is a base, it accepts a proton and get converted to acid, right? Therefore this is another acid base pair. This is the another acid base pair, because this base accepts a proton and therefore it becomes an acid. Therefore this is the another conjugate acid base pair. Okay, conjugate acid base pair. This is the another conjugate acid base pair. If we consider here there a pair, if we consider this pair or if we consider this pair, then we can say that there is a it is just differ by a proton. अभी यहाँ पे HCl है, HCl देख लिया हमने एंड Cl नेगेटिव आयन, ये जो कॉन्जुगेट एसिड बेस पेयर है दिस वन, तो देयर इज ओनली अ डिफरेंस ऑफ द प्रोटॉन. यहाँ पे प्रोटॉन है, यहाँ पे प्रोटॉन नहीं है. तो जो कॉन्जुगेट एसिड बेस पेयर रहते, इट इज जस्ट डिफर बाय अ proton. If you also consider this conjugate acid base pair of H2O and H3O molecule, again here there is a difference of a proton, right? Therefore this is a conjugate acid base pair. Therefore we can say that the conjugate acid base pair is a pair of an acid and a base which is differ by a proton or presence or absence of a proton, because here there is a presence of proton, here there is an absence of proton. Therefore this is acid and this is base, right? Thus this is the Laurie-Bronsted concept of an acid and a base, and the conjugate acid base concept according to the Laurie-Bronsted concept. Now we are going to see the Lewis theory of acids and bases. Now this Lewis theory is more generalized theory and it is just based on the electron transfer concept. Therefore it is more generalized theory, right? Then according to the Lewis theory, a species that accepts a share in an electron pair, इलेक्ट्रॉन पेयर में जो भी कोई शेयर एक्सेप्ट करता है, then according to Lewis theory it is an acid. A species that accept a share in an electron pair is an acid according to the Lewis theory. And बेस कंसिडर किया तो यहाँ पे any species that donates a share in the electron pair is a base. तो यहाँ पे हम एग्जाम्पल देखेंगे. तो जो अभी यहाँ पे H पॉजिटिव आयन है, सपोज हियर दिस इज H पॉजिटिव आयन इज एन एसिड, ये एसिड हो गया. तो यहाँ पे हमने उसका रिएक्शन कर लिया सपोज, तो यहाँ पे ये जो अमोनिया है NH3 इट इज़ ए बेस, बिकॉज क्या है अमोनिया यहाँ पे बेस है, तो इसका लोन पेयर है अमोनिया का यहाँ पे, राइट। तो अमोनिया का लोन पेयर जो अभी यहाँ पे पॉजिटिव है और यहाँ पे लोन पेयर है, तो वो लोन पेयर में शेयरिंग होगा, यानी कि एक्सेप्ट करेगा इलेक्ट्रॉन, इलेक्ट्रॉन पेयर का शेयरिंग ये यहाँ पे ये जो एसिड है वो एक्सेप्ट करेगा इसके साथ। देयरफॉर दिस इज एन एसिड एंड दिस इज अ बेस। इट इज़ अ बेस बिकॉज इट्स डोनेट्स अ शेयर पेयर of an electron to the acid H positive ion. Therefore this is acid and this is base, and here you will get the NH4 positive ion. You will get here the NH4 positive ion. Now again we will see the another example. Suppose this is BF3. BF3 है यहाँ पे, तो it is more electronegative. Okay, it is more electronegative and it always accept a share in an electron pair because it is more electronegative. And here ammonia, there is a lone pair of electron is there on this nitrogen, and therefore it always donates a share in an electron pair. Okay, and this acid will, this BF3 will accept a share in an electron pair. Therefore it is a acid and this is a base, and therefore you will get here a compound. and यहाँ पे इसके वजह से शेयरिंग ऑफ इलेक्ट्रॉन हो रहा है, देयरफॉर यहाँ पे कोऑर्डिनेट बॉन्ड तैयार होता है। ये कोऑर्डिनेट बॉन्ड यहाँ पे हो जाता है, कोऑर्डिनेट बॉन्ड यहाँ पे बन जाता है जब ये दोनों एसिड एंड बेस रिएक्ट हो जाते हैं तब। Okay, right, this is according to the Lewis theory. According to the Lewis theory, acid is a species that accepts a share in an electron pair, while a base is a species that donates a share in an electron pair, and therefore there is a formation of a coordinate bond, right. Thus the acid react with bases to share a pair of electrons, but still there is no change in the ऑक्सीडेशन नंबर ऑफ एनी एटम। तो यहाँ पे कौन से भी एटम का ऑक्सीडेशन नंबर चेंज नहीं हुआ है, बोरॉन का भी नहीं हुआ है और नाइट्रोजन का भी नहीं हुआ है, और नो चेंज इन द ऑक्सीडेशन नंबर ऑफ दिस फ्लोरीन एटम्स। Thus acid reacts with base. Here acid react with the base, but to bases to share a pair of electron, but still no change in the oxidation number of any atom. Okay, this is according to the Lewis theory. Now we will see the amphoteric nature of water. तो एम्फोटेरिक नेचर ऑफ वाटर ये अपने को देखना है। तो एम्फोटेरिक सब्सटेंसेस मीन्स क्या है? तो एम्फोटेरिक सब्सटेंसेस जो है, द सब्सटेंसेस विल बोथ एक्ट एज बोथ एज एन एसिड as well as a base. Those substances are said to be the amphoteric substances. Now just we will see the example here. We will take the example of water molecule and the ammonia. We already have seen this the example. H2O here liquid, okay, and NH3 is the aqueous solution इसका यहाँ पे है। तो दिस इज द रिवर्सिबल रिएक्शन, ओके। देयरफॉर वी हैव जस्ट रिप्रेजेंटेड इट बाय द टू arrows, that they are half headed arrow, and here we can say that this the OH negative ion will be produced here. OH negative ion will be seen there, and this is here the NH4 positive ion in this reaction. तो यहाँ पे जो है H2O मॉलिक्यूल, अभी यहाँ पे H2O मॉलिक्यूल जो है, here the H2O molecule, we will see here the H2O molecule act as an acid, right? It will act as an acid here, and therefore according to the Laurie-Bronsted concept, an acid is a substance that donates the H positive ion और द प्रोटॉन। तो यहाँ पे H2O का जो है, तो H2O हमने यहाँ पे देख लिया सपोज, तो H2O को यहाँ पे ऑक्सीजन पे 2 लोन पेयर्स है, राइट, एंड हियर 1 हाइड्रोजन इज देयर, हियर 1 हाइड्रोजन इज देयर। तो यहाँ पे जो H2O है, तो it will donate a प्रोटॉन एंड देयरफॉर इट विल एक्ट एज एन एसिड। तो यहाँ पे ये एसिड हो गया है, वाटर मॉलिक्यूल इस रिएक्शन में एसिड, इट एक्ट्स एज एन एसिड इन दिस रिएक्शन, एंड देयरफॉर हियर द OH नेगेटिव आयन इज प्रोड्यूस एंड प्लस NH4 पॉजिटिव आयन इज produced in this reaction. Now if we'll consider the another example or another reaction, then it is here in H2O molecule plus HCl. Okay, H2O liquid plus HCl aqueous medium, so it will give the H3O positive ion, and here the Cl negative ion will be there. Now in this reaction, now in this the HCl, here it will, there is a H positive ion, right, and the Cl negative ion in this. The now this HCl, here it will just donate a H positive ion to the H2O molecule, and therefore the H3O positive ion is produced. Then according to the Lowry-Bronsted concept, the substance that accepts a accepts a H proton or H positive ion, then it acts as an acid, base, it will act as a base. Therefore in this reaction the water molecule acts as a base. Here we have seen that the HCl, it is chlorine is more electronegative, therefore the here the H positive ion will be produced like this, and this H positive ion, it is accepted by the water molecule, and therefore according to the Lowry-Bronsted concept, Lowry-Bronsted concept, here H2O molecule act as a base. Thus according to the Lowry-Bronsted concept, here H2O molecule, this water molecule, act as an acid as well as it act as a base, therefore it is amphoteric in nature. Thus we have seen here the different concepts of acid base, that is we have seen the Arrhenius theory of acid and bases, we have seen the Lowry-Bronsted theory of acid and bases, we have seen the Levy's theory of acids and bases, and we also have seen the amphoteric nature of water. Okay, bye, see you.